Okay, today we see the problems based on Heisenberg uncertainty principle. Okay, so see the problem. The uncertainty in position of a minute particle means a very small particle of mass 25 gram in space 10 power minus 5 meters. So what is the uncertainty in its velocity? Okay, it is given that uncertainty its position is 10 power minus 5 meters. Okay, so what is the uncertainty its velocity? So what is the formula for uncertainty principle in terms of velocity? So delta x mass delta v equals h by 4 pi. Here we need to calculate uncertainty in velocity. Delta v become h by 4 pi mass into delta x. Okay, now the delta v is equal, what is h? It's a Planck's constant. Here we are taking in SI method, joule into second, pi value 3.14. What is the mass? 25 grams. So we need to convert it into kg because we are following the SI method. 25 into 10 power minus 3 kgs. Okay, this is important. Conversion of grams into kgs. Next, delta x. What is delta x? 10 power 5 meters. So already is present in SI method. So no need to convert it. So now the delta v is equal 4 by multiplying 4 into 3.14 into 25. So here approximately we will get 314 into 10 power minus 8. So on this calculation we will get minus 34 become plus 8. So how much now? It is equal to 26. So in normal 2 points we converted them, 2.10 power minus 28. So velocity means centimeter per second or meters per second. Here we are following SI method. So all it is given, we need to calculate in meters per second. Kabatti SI method total units మొత్తం మన SI method లో తీసుకోవాలి. So meters per second. Okay, so this is a calculation of uncertainty in its velocity. Okay, write down. Three minutes. Okay, see the next one. The uncertainty. So uncertainty means we know that error. Okay. The uncertainty in momentum means p. Mass into volume is given of a particle is 3.31 into 10 power minus 2 kg meter per second. So mass into velocity here. Mass into velocity. So find the uncertainty in its position. So what is the formula? Delta x. We need to take the formula in terms of momentum. So in terms of momentum, that is delta x. So just a minute. Okay, so what is the formula in terms of momentum? Because momentum is given h by 4 pi. We need to find the uncertainty in its position. Okay, that is h by 4 pi delta p. H. Sorry, they followed the SI method. That's why we are taking in SI method, that is joule into second. Here pi value is 3.14 What is delta P given? Oh, minus 2. So on this particular calculation, so approximately we will get approximately here 3.31. Okay, that's what is given, 10 power minus 2 kg. Okay, this weight. Okay, sorry, there is a difference in the problem. 10 power, okay, we'll take this only. So on this calculation we will get approximately so now we get so 12.56 again. Minus 34, it becomes 10 square. Okay. So on this calculation, approximately we will get 41.57. Again, on this calculation, we will get approximately 0.1592 510 minus 32. So it belongs to the position. Means what is the final delta x we can write? 33. So already we totally followed the SI method. So it is in meters. Okay. So here important thing is so which value is given, which value we need to find. That's important. Next is check the units. Units are very important. So to test the total units SI method lo unda lekapothe total unit must be in a CGS method. Okay, SI lo okati CGS lo unte we will get the wrong answer. Okay, next here important one is calculations. So here now we are taking the calculation just with the help of the calculator. But you need to practice the calculations also. Okay. Okay, see the third one. So calculate the uncertainty in the position. Means we need to calculate delta x of a cricket ball having mass 150 grams. Okay. If uncertainty in its velocity is given 3.52 into 10 power minus 24 meters per second. Means here mass is given. So what is the formula? Delta x mass in terms of velocity h by 4 pi. Here we need to calculate delta x. X equal, there is h by 4 pi m into delta v. Now substitute the values. So the delta x equal to 6.625 into so 10 power here meters per second is given. Mass, what is the mass? 150 grams. But we took Planck's constant in joule into second, and here it is given in meters per second. So we need to follow the SI method. So we need to convert the mass into kgs. Okay. Power minus 24. Delta V is given that. So 34. So on this total calculation, 4 into 3.14 into 150 into 3.52. So on this total calculation, we will get approximately 6631.7 into 10 power, this minus 3 minus 24. Here we get minus 27. Again, on this. In these problems, in this type of problems means Heisenberg problems, calculations are very important. Okay. So on this dividing, we will get approximately 0.0009 into 10 power 34, that is plus 27 minus 27, sorry, it's only minus 7. Okay, so here approximately, so we can conclude a final value, that is 3 points. Okay, that is make it 0.99 and for minus 3 to become minus 10. So approximately it can taken as 1. So delta x is equal to 10 power minus 10 meters. So which can be written as 1 angstrom. Okay, so this is the uncertainty. Uncertainty in its position. If its mass is 150 gram, its uncertainty in velocity is this much. Okay, so write down. Okay, see the next problem. So the size of a microscopic particle is 1 micron. This is called mu. Okay, mu. Given as 1. So this symbol indicates mu. So which is equal to 10 power minus 6 meters. Okay. And its mass is given 6 into 10 power minus 13 grams. If its position may be measured, here important one, direct uncertainty in position is not given. It is given in terms of percentage. If its position may be measured to within 0.1%, అంటే దీంట్లో ఎర్రర్ ఎంత వస్తుంటే 0.1% ఆఫ్ ఇట్స్ సైజ్. ఓకే, సో దాని సైజ్లో 0.1% అన్సర్టెనిటీ వస్తుంది. Then we need to find the uncertainty in its velocity. నీకు సో ఇప్పటిదాకా చేసిన ప్రాబ్లమ్స్ అన్సర్టెనిటీ డైరెక్ట్గా వాల్యూ ఇచ్చింది మరి, పొజిషన్ కానీ వెలాసిటీ కానీ. ఇక్కడ అన్సర్టెనిటీ గివెన్ ఇన్ టర్మ్స్ ఆఫ్ పర్సెంటేజ్. ఓకే, సో ఈ పర్సెంటేజ్ దేంట్లో ఒక 0.1% ఈజ్ గివెన్ ఇన్ ఇట్స్ సైజ్. అంటే సో ద ఫార్ములా ఫస్ట్ వి రైట్ ద ఫార్ములా. ఓకే, సో మాస్ ఇంటూ వెలాసిటీ h by 4 pi. Here we need to calculate the uncertain velocity. Delta v is equal to h by 4 pi mass into delta x. Say it is equation 1. Okay. So now we know that 1 micron means 10 power minus 6. Okay. Oh, we know the what is mass. Mass is given 6 into 10 power minus 13 grams. Okay. And so we are converting it to kgs. Okay, kgs means minus 13 grams to minus 3 kgs. That is equal to 6 into 10 power minus 16 kilogram. Okay. So next, what is delta x? So delta x is 0.1% in its size. What is its size? 1 micron. 1 micron means 10 power minus 6 meters. Okay. So దీంట్లో 0.1%. That is 0.1 by 100. Okay, that is total become, so minus 6. 0.1 minus 1, this becomes 10 power minus 2. Total is, what is the uncertainty in position is 10 power minus 9 meters. Okay, now we substitute that values in the equation 1. Okay, delta v is equals, so total SI method following kabatti minus 34 by, so what is the mass? Mass is 6 into 10 power minus 16 kgs. Okay. What is delta x? 10 power minus 9 meters. So here on this calculation, so approximately we will get is equal to 6.625 into 10 power minus 34 by here 12.56 and into 6. Okay. Okay, so on this calculation we will get 12.56 6 alpha minus 25, that is 6.625 34. But so on this calculation we will get approximately 75.36. Okay, so again, so on this calculation, so here we will get approximate 0.079 into 10 power minus 9. So delta V, that is meters per second. So this is uncertainty in its velocity. Just earlier problem ki just small difference is it is given in the micron. Micron means 10 power minus 6 meters. Okay. Next, uncertainty in its position is given in terms of percentage. Okay, remaining problem same. The important thing is, so మనం maximum problems లో ఇక్కడ SI units తీసుకుందాం. It is not compulsory. ఎప్పుడు SI unit తీసుకోవాలని there is a no criteria. So you can take a CGS method. ఇక్కడ R తీసుకుంటే ఇది సెంటీమీటర్స్ మొత్తం మాస్ ఇది గ్రామ్ లో కన్వర్ట్ చేయాలి. The thing is all must be in SI method or all must be in CGS method. Okay, write down. Let's see the next one. So the uncertainty in the position of an electron moving with a velocity of, means here exactly velocity is given, is accurate only up to 0.011%. Means so how much uncertainty is there? Uncertainty is 0.011% of its velocity. Means here delta V is given how much? Not directly given, here also percentage is given. Delta V is equal, so velocity how much percentage? 0.011%. Okay, so that is equal to approximately will tens become 10 square. Okay, here we will get 0.033 10 square, that is in meters. Sorry, it is given in terms of centimeter per second. Okay, centimeter per second. Next, we need to calculate what? Uncertainty in the position. We need to calculate delta x. So what is the mass? So what is the particle here? Electron. So what is the mass of electron? 9.109 into 10 power minus 31 kgs generally. But here, so centimeter per second. So in this problem we follow the CGS method. Okay, మనం ఇష్టపడి follow అవచ్చు. No problem. Here minus 31 kgs. What is the electron mass? Minus 28 grams. Now substitute the values. So what is the formula? Delta x into m into delta v is equal to h by 4 pi. So we need to calculate which one? Position. That is delta x equals h by 4 pi m into delta v. Okay. Now substitute the values. So now what is the value of h? Here we follow the CGS method, means delta V velocity is in centimeters per second, mass is in grams, so it must be in ergs into second. What is value in erg into second? 10 power minus 27. 4 into, what is the pi value? What is the mass? 9.109 into 10 power minus 28 grams. This is for electron. What is the delta V? 0.0, that is 10 square. Okay. And here important again the calculation. So the calculation 4 into 3.14, 9.109 and 0.033. So on this calculation approximately we will get 3. Minus 28 is approximately 30, and this is given minus 30. Okay, so now we see this calculation again. Okay, so on this particular calculation we got that 3.775. Okay, so minus 28, this plus 2 means minus 26. So again on this calculation, so again we get approximately 1.7547. So this plus 26 means 175. So what are the units? Delta x position, CGS, we follow the total CGS method, that is centimeters. Okay, so this is the uncertainty in the position. Okay, write down. Okay, here in this problem it is given about two particles, comparison between two particles. So the uncertainties of in the velocities of two particles, let's say A and B, means uncertainty is directly given in velocity, that is one is 0.05 for A particle, for B particle it is 0.02 meters per second. So the mass of B is 5 times to the mass of A, means mass of B is 5 times greater than A. So find the delta XA by delta XB. And we find out we need to find the ratio of uncertainties in the position. So uncertainties in their position, find out here. First we write the equation for particle A. Okay, for A particle we are writing delta XA, mass of A, uncertain velocity of A is equal h by 4 pi. Okay, all are constant, no need to write the particular A. So we need to find this one, delta XA. So but simple, we convert it into delta XA is equal, we can write h by 4 pi mass of A and uncertainty in velocity of A. Say it is equation 1. Now write for particle B. For B particle, delta XA, sorry, we are writing for B, delta XB, mass of B, delta V of B is equal to h by 4 pi. Okay. We need to check delta XB. Delta XB find out here. H by this 4 pi into mass of B into delta VB. Okay. Say it is equation 2. So మనం find out చేయాల్సింది exactly delta xa by xb. In the equation 1 we got delta xa. In the equation 2 we got delta xb. Just మనం ratio find out చేయాలి. Delta xa by delta xb. So that is the equation 1 by 2. Let's do equation 1 by 2. Here we get h by 4 pi mass of A delta VA. Okay, mass of A delta VA. So by means exactly reciprocal అవుతుంది. 4 pi mass of B delta VB by H. Okay, so on this calculation, so what will be cancelled? 4 pi get cancelled, H get cancelled. So what is the remaining one? Mass of B into delta VB by mass of A into delta V of A. What is mass of B? It is 5 times to the mass of A. So mass of A just 1 తీసుకున్నాం, it becomes 5. It is your choice to తీసుకుంటే into 5 10 తీసుకోవాలి. If you take the 100, you take 500, that's 5 times. Delta VB how much? Uncertainty of velocity in B. So B particle 0.02. In A particle there is 0.05. Okay, I will cancel this point, becomes 5 get cancelled. Okay, so that is equal to 2. Means the ratio of delta x by delta xb, that is exactly equal to 2. Okay, so these are the 3 type of problems. In first earlier 1 2 3 problems, directly delta x or delta v, one of them is given. Like second type of percentages are given. In third type we need to calculate the ratio. Okay, now take the 2 problems. So the 7th one is the direct question, the 8th one is just somewhat different, so try to do the using the same formulas. Okay.